Good morning, sir.
Good morning. Okay, I'm looking at the attendance. It is very poor since last 3 lectures. Around 70 or 80 students are there, not more than that. So this will not be acceptable if department can take certain action regarding. Okay, so here, as we have seen in previous lecture, the stability concept of the transfer function or the system, and we have seen a straightforward methodology to calculate roots or poles of the system. Accordingly, we may take decision whether system is stable, margin is stable or unstable. Later on, if the order of the polynomial is more than say 6, 8, then it could be quite difficult to compute straightforward way. So there is one methodology called RH, that is Routh-Hurwitz criteria. Accordingly, we have solved certain examples in previous lecture. Now we'll continue with the same. Before that, I will share my screen. Okay. So I hope the PPT is visible. There is a auxiliary polynomial example 1 on your screen. Is it? Is it visible to you?
Yes, sir.
Yes, sir.
Okay. Now, last time we have seen if two consecutive zeros are in certain row, then we take, say, just above that row and make an auxiliary equation and derive it with respect to s, and later on whatever are the coefficient of auxiliary equation kept in place of the zero. Now in this example, this thing happens twice. So this is the characteristic equation. You can see s to the power 4 plus 2s4 plus 2s cube plus 4s square plus s plus 2 equal to 0. So route table can be formed like this. I have taken this s5 here, then s to the power 4 here, and then the coefficient of alternate, that is s5 coefficient is 1, s cube coefficient is 2, and s coefficient is 1. So it is 1 to 1 here. Then s4, s to the power 4 coefficient is 2, then s to the power 2 coefficient is 4, and later on it is s to the power 0 is nothing but coefficient is 2. So it is 2, 4, 2. If you revise this 2, 4, 2, you may divide this complete row with 2. So it may be 1, 2, 1. No worry about that. You may write that. And I'm interested in last, say, s to the power 3 in the route table. So you can compute, just see the example here. Like this is 2. So I'm interested in computing this. So 2 into 2, 4, minus 1 into 4, 4. So 2 minus 4 minus 4, it will be of course 0. Divide by 2 is 0. Similarly, it happens here. That is 2 into 1, that is 2, minus 1 into 2, that is 2. So it will be of course 0. So here, and next row is here. If you consider here, it is already 0, so you can take it 0. So here 0 is there. So what we do in this case, we just go for the upper line, that is जहाँ पे 0 है उसके ऊपर का रो हम लेते हैं s4 वाला, s to the power 4. Therefore the auxiliary equation is given by s to the power 4. You may write like this: 2s to the power 4 into 4s square, sorry, plus 4s square plus 2, and divide complete equation with 2, or take 2 common. It will be s to the power 4, then 4 divided by 2, that is 2, 2s square plus 1 equal to 0. Then we'll derive this with respect to s. It will be 4s cube plus 4s plus 0. So you can see what are the coefficient. We are interested in replacing these two zeros with the coefficient of the auxiliary equation obtained here. So s cube ka coefficient is 4 and s coefficient is 4. So you may replace this 0 0 by 4 4 and you may take 4 common. It may be 1 1. No worry about that. You can. So these two zeros are replaced by 1 1. I hope you understood. If you take this 4 common, then it will be s cube plus s. So there will be 1 1. So we took this coefficient and again, sorry, here we took this coefficient 1 and 1, then again did the same. Here I want degree of 2, that is s square. Then this result will be 1 into 4, that is 4, minus 2 into 1, that is 2. So result will be 2, divided by 1, it will be 2. It will be what? 2. Then later on this one, this will be 2 into 1, that is 2, and 2 into 0, that is 0. So 2 minus 0 divided by 1 will be also 2. So this row comes 2 2. Again I said if it is a common, then you may divide a complete row. So dividing by 2, it will be 1 1. Similarly you can do it here. 2 4 2 hai, you may write 1 2 1, you will get similar result. So this is 1 1. Later on we'll come down for the next degree, that is s to the power 1, and do the calculation. I'm interested in this bit. So 1 into 1 minus 1 into 1, that will be of course 0. Again this will be here, right? 1 into 0 0, so it will be 0. So you can see there is repetition of the previous, say, condition. So entire row is 0 for s to the power 1. So again we will do the same thing until we reach up to s to the power 0. So entire row is 0. The auxiliary equation you have to write for just above 0th row. So what is that? S square wala and 1 1. So it will be s square plus 1. So your auxiliary equation a dash se likha hai, second hai isliye it will be s square plus 1. Deriving that with respect to s, it will be 2s plus 0. Then what is the coefficient now? It will be 2. So let's put that coefficient. You can see here 2. Let's put that coefficient here. Then again calculate for s to the power 0 wala term. So this will be what? 2 into 1 minus 1 into 0. यहाँ 0 बोल सकते हैं आप. So it will be 2 divided by 2 will be of course 1. Okay. So just observe the first column. Now we did with this complete s raised to 5 up to s raised to 0. So complete root table is with you now. Just observe the first column and observe the sign. For every element in the first column, the sign is positive. Thereby it is, say, observed that system is to be stable. But this is not the only condition. You got two auxiliary equations here, and roots of the system or poles of the system is nothing but the poles of the auxiliary equation. You may find out the poles for this equation, that is what? S cube plus s is equal to 0 put karke. You may find out, of course, by forward way. You may find out the, sorry, for this s to the power 4 plus 2s plus 1 is equal to 0. इसके लिए आपको poles find out करने हैं manually, of course, because now the degree is less. Or you may use RS table again. And here for this also you will get the poles. S square plus 1 is equal to 0. That will be s square is equal to 0. That will be plus minus j will be the answer. So if you calculate the pole, we'll see this in another example how to calculate. There is no sign change in first column. The roots of the auxiliary equations are plus j minus j. इसने direct निकाला है. So we'll take that later on. We'll calculate plus j and minus j. That is repeated root on the imaginary axis. So here we have seen if the repeated root on imaginary axis, repeated means at the same location two or more than one. That is the repeated. Repeated is not like that. If I have imaginary axis like this, and if I have pole here, and if I have pole here, again here and here, this is not repeated. Repeated means it is at exact location. You can see plus j पे 2 है और minus j पे 2 है. In that case, your response is like this, and hence the system is unstable. So this is the exception. What is the generalized rule that we have seen till the time? If the first column is positive, all coefficient are positive, then system is stable. But here, due to the auxiliary equations came into the picture, we have to calculate the roots of the auxiliary equation, and if it is repeated, of course, then you may directly comment that system is unstable. We'll see this again in next example. Okay, now I will put one example in front of you. I wanted to solve this example by you. What is the question? Determine the stability of the system whose characteristic equation is s to the power 4 plus 2s cube plus 8s square plus 4s plus 3 is equal to 0. Also comment on the location of the poles of the system, and of course you have to get the root array. So I will provide you 4-5 minutes, and I'll ask you the first column of the root array only. First column. You may write into the chat box separated by comma. Suppose first column is 1, 2, 3, 4. So write 1, 2, 3, 4. So I will get it at my say terminal. Okay. So you please write down, because I am minimizing this window. S to the power 4 plus 2s cube plus 8s square plus 4s plus 3 equal to 0. Please write it fast. And provide me the first column of the RH table. Is chat enable for you people? Can I chat into the box? Yes, those who got answer, type the first column into the chat box. Let me see. Yes, be fast, because I have to cover 5 numericals within 45 minutes now. And those, yes, first column is
116 3 by 2 3.
116 3 by 2 and 3.
Yes, sir.
Try it again. Try it again.
Hello, sir.
Yes.
12633.
Yes, it is the right answer. The who is speaking? Yeah, Priyanka. It is 12633. So based on this answer, system is stable or not?
System is stable.
Yes, because all the coefficients are positive and there is no auxiliary equation, so no need to think of calculating roots or the poles of the system. I'll again share my screen and I'll come back to you, those who may have problem while solving this numerical. I'll go through it. So this was the characteristic equation provided. Then what we do, we go for S4 highest degree, then S to the power 3, S to the power 2, S to the power 1, S to the power 0 ये लिख लेना है. Then we go alternate even पहले S to the power 4 उसका coefficient, then S to the power 2 and S to the power 0 means 1. So it will be what? 1, 8, 3 are the coefficient. Similarly for S cube ka coefficient, then S ka coefficient. So it will be S cube coefficient is 2 and this coefficient is 4. So after writing these two rows of the root table, then calculate the further order elements. So S square के लिए अगर निकाल रहे हो, this element I want. So cross multiplication 2 multiplied by 8, so it is 16 minus 4, that is 4 multiplied by 1. So it will be 12 divided by 2. So 12 divided by 2, it will be 6. Similarly, calculating for this, it will be 2 multiplied by 3. So it will be 6 minus 1 multiplied by 0. It will be, of course, 6 divided by 2 will be 3. Again, go for another, that is S to the power 1. So this element is calculated like keeping the in mind upper element. So 6 into 4, that is 24 minus 2 into 3, that will be how much? 6. So 24 minus 6, it will be 18 divided by 6 will be of course 3. And here ये 3 as it is आता है क्योंकि इसके लिए ऐसा calculate करना पड़ता है. It is 3 into 3 minus 6 into 0. So it will be 9 divided by 3 itself. So it will be 3. So this is the answer, Priyanka. Your answer is right. And all the elements are positive. You can see all the element in first row is positive. Therefore, we can directly, as there is no, you have to make statement, no change in the first column, change in the sign of the first column of root array. Therefore, all the roots or pole are located in left hand plane of S plane. Hence, the system is stable. I'll provide you the next example. Please interrupt me if somebody is not getting the things because it already covered in the previous lecture. So I may go bit faster, but you have say all rights to interrupt me if you're not getting the things. Okay, please go for this and give me the first row, sorry, first column of root array. The characteristic equation is this. Please write it down because I'm minimizing this. It is S to the power 5 plus S to the power 4 plus 3S cube plus 9S square plus 16S plus 10 equal to 0. I hope you wrote this characteristic equation. I'm going to minimize it. Please check the coefficient. If you make coefficient wrong, then complete answer will be wrong. You may either write into the chat box the answer separated by comma. Mahesh expecting right answer now. Only 65 students are attending the lecture. I think you're not serious about. You're thinking that all the exam will be online and you will get, say, degree certificate. It is not like that. You will be zero into the market if you don't know anything about, say, the subjects of all years. Yes, Bhagyashri, did you get answer? Bhagyashri Agrawal?
Trying, sir.
Yeah.
So 116 6.3 16 0
1
6
huh?
6.33 16 0
No. Please verify it again.
Hello, sir.
Yeah, Priyanka.
1, 1, minus 6, 10, 12, 10.
Yes, it is right answer. It is 1 minus 6. I'll show to all of you and I'll again tell you the calculations. So it is 1 minus 6, 10, 12, 10. So what about the stability?
The system is unstable.
Yeah, system is unstable because there is a minus sign in first column. And is my screen visible at your end?
Yes, sir.
Okay, so this is the answer. So this is degree is s to the power 5. So I wrote everything up to s to the power 0 in this way. Then the coefficient s to the power 5 ka coefficient, then s to the power 3, then s. So it will be 1, 3 and 16. Then for s to the power 4, उसके coefficient लिखना है s to the power 4, s to the power 2 and s to the power 0. So it is 1, 9 and 10. Just have calculations, those who made a mistake or have not tried for the answer. ये आंसर चाहिए हमें, ये रो empty है, इतना ही लिखा था हमने, ये दो इतना ही लिखा था. So how to calculate this? I will again repeat it. क्रॉस मल्टीप्लीकेशन, इसके अबो एलिमेंट जो है उसका नंबर देखना है, इसका क्रॉस मल्टीप्लीकेशन करना है. सो इट इज 1 into 3, so it is 3 minus opposite वाला क्रॉस 1 into 9, that is 9, so it will be 3 minus 9, so it is minus 6 and divide by this element itself. ये वाला मैं राउंड कर रहा हूं यहाँ पे बहुत बड़ा. So minus 6 divided by 1 will be minus 6. Let's go for the another element. ये हमें निकालना है, बट इसे ही रेफरेंस पकड़ना है हमें 1 को, 9 पे नहीं जाना है. I think you are going to this one, so that is wrong. So I'll go for this element now. So it will be what? 1 into 16, that is 16, minus 1 into 10, that is 10. So 16 minus 10, it will be 6. Divide by this element, first element, that is 1. So it will be 6. So in this way we got minus 6 and 6. Then we'll move for the next element. यहाँ तक निकल चुके हैं हमारे. I'll mark it here. Then I'll go for s to the power 4. So I'm interested in this element. So just above क्या है वो देखना है. And the cross multiplication with sign, of course. Just next to that. So 6 into 9. कितना आता है?
54.
54 minus this 6 and divide by this minus 6. minus 6 से divide करना है. So it is 10. Then it is 10. And again next element निकालना है हमें. Next element minus 6 को base पकड़ के. So minus 6 into 10, it will be minus 60. Minus 60 divided by 0. Minus 60 divided by 0, sorry, minus 60 minus 0 divided by minus 6. देखो minus 60 divided by minus 6 है, so minus minus get cancelled and it will be 10. Again moving to the next, same is the procedure. I am interested in this now. So इसके above क्या है ये देखना है हमें. So 10 into 6, 60 minus 10 into 6, but minus 6 है, so it will be minus 60. So 60 minus of minus 60, it will be 120, and 120 divided by 10 will be of course 12. So we got this one. Later on यहाँ पे एलिमेंट नहीं है तो आगे कैलकुलेट करने की जरूरत नहीं, यहाँ का कोई सोचने की जरूरत नहीं. Then I want last degree, that is s to the power 0. I'm interested in this element. कैलकुलेट करना है, यहाँ पे रेडी आंसर है बट इट हैज टू बी कैलकुलेट. सो उसके ऊपर का एलिमेंट 12 into cross multiplication 10, that will be 120 minus 0 divide by 12. So 120 divided by 12, you will get 10. So you can see here how many poles are there then. Of course it is unstable, but how many poles are there? Just see the sign change. Not one, there will be two. There is a sign change here. They are not of same sign, so it is of course unstable system. But I'm interested in the number of roots or number of poles. Look at the sign change. Positive से यहाँ negative हुआ है, negative से फिर से positive हुआ है. So there are two sign changes. So as there are two sign changes in the first column of the root array, therefore two roots or poles are located in right hand plane. Means we don't know the exact location. यहाँ पे कहीं पे दो poles हो सकते हैं, बाकी के pole of course इधर है, but our statement is if any of the pole is in right hand side, then system is unstable. So this is system is unstable. Move to the next. Solve this. Whatever we learn in earlier lecture, you may get different equation. You may get 0 in certain element, you may get complete row 0. So you have to apply the rules. That is auxiliary equation wala. Please write it down and solve it. S to the power 5 plus s to the power 4 plus 2s to s cube plus 2s square plus 3s plus 5 is equal to 0. And solve it. We'll solve for the roots or poles later on in the next PPTs. First of all, we are interested in stability and number of roots present in RH. It may take certain time. Please write down the equation because I'm going to minimize the PPT. The answer will be of course different because you will be getting 0 in the first element of s square. So you know what to do for 0. If 0 is there, put epsilon and calculate accordingly. Equations आएंगे कुछ. So in first column there will be element along with equation. S cube में first element 0 आ जाएगा आपका. So epsilon put करना है and epsilon is small value, small positive value near to 0. ज़्यादा सोचना नहीं उसके बारे में. Or you can say it is 0 but positive. Either way you can talk.
Hello, sir.
Yes, who's
Hello?
speaking?
Mahesh.
Mahesh. Yes. Tell me the
One,
coefficients. Yes, of course. 1
epsilon,
yeah.
epsilon plus 2 by epsilon.
नहीं, ये बताओ एप्सिलॉन के बाद का एलिमेंट क्या बताया?
epsilon रो सांगायचं सर की कॉलम?
नाही, फक्त कॉलम सांगायचा एका खाली एक. 1 1
sir,
e चाललं तुझं 1 1 एप्सिलॉन, then
2 epsilon plus 2 by epsilon.
Yeah, right. Next, s to the power 1.
Then sir, minus 2 epsilon plus 2 by epsilon multiplied by 2 minus 5 epsilon by 5 by 2 epsilon plus 2 by 2.
Okay, whatever it may be, you might
It is, sir,
have
there is
not solved
negative.
it. Okay,
There
yes,
is
it is
negative.
negative, of course. And the last
And
element
power
of the
0
column,
is 5. Yes,
5,
power
right?
0 is 5. So
Yeah, yeah.
two sign changes, hence right hand poles are 2. So it is
Yeah,
unstable system.
yeah, it is unstable. So I'll again come back to those people who have not solved or not understood this numerical. So working with the same, I will put the coefficient of S5 and S4. Then it will be S5 ka 1, then directly S3, that is 2, then S, that is 3. So I have 1, 2, and 3 in the first row of the RH, root array. Then S4, S4 ka 1, then S2 ka 2, then 5. So it is 1, 2, and 5. So let's calculate. ये दो रो निकलने के बाद I am interested in this row, and that has to be calculated. Please make your attention. So I am interested here. मैंने E लिखा है लेकिन E क्यों लिखा है? What will be element here? It will be just above, that is 1. 1 into 2, that is 2. Minus 1 into 2, that will be 2. So 2 minus 2, it will be 0. So there is 0 coming here in the first element of the degree 3. Therefore, here we replace 0 with epsilon, which is of course positive, we assume, and it is near to the 0, very, very small. Later on, I'm interested in this element. So this element is calculated in, say, similar way. 1 into 3, that is 3. Minus 1 into 5, that is minus 5. So 3 minus 5 is 2. Divided by 1, it will be, of course, minus 2. Now this row is over. We replace 0 with epsilon. Then do the calculation as per the rule of our root array. So we'll do that. So हमें ये निकालना है अभी, ये वाला. So it will be 2e cross 2e, minus of minus 2 will be plus 2. So 2e plus 2 divided by e. I got the answer. Let's go for this. This will be simply ये वाला element. आप करोगे तो भी दिखेगा 5e minus 0 divided by e. 5e divided by e will be 5. So I got the next element here. Now I am interested in next order of the root table, that is this one. So if you calculate ye cross multiplication, that is minus 2, so it will be minus 4e minus 4 divided by e minus 5e divided by this term. और इसे solve करोगे, you will get this answer. 5e square minus, of course, minus 5e square plus 4e plus 4 divided by 2e plus 2. So we got a minus sign. Again, कहाँ तक जाना है? S to the power 0 तक. तो ये element निकालना है. If you do the cross multiplication, this multiply by this, again divide by this will be 5. ये direct ही आता है. No need to calculate it. So 5. So look at the first column here. And you can see two sign changes. Positive से negative गया है, negative से positive गया है. So as there are two sign changes in the root array, therefore two roots or poles are in right hand plane of the S plane. Hence the system is unstable. Okay. And if you wanted to calculate the value of element here, यहाँ पे क्या वैल्यू है ये अगर कैलकुलेट करना है, you can, you know, e is equal to 0 but it is positive. So put limit e is equal to 0 into this. So you're putting 0 here, you will get answer 2. Means here approximate value will be of course 2. And if you put e is equal to 0 here, you will get answer minus 2. Okay, if you want further clarification. So this is the route array. Accordingly, we obtain or say commented on the stability of the system. Now moving next, that is the fourth example. I'll directly explain you the fourth example. I'll not ask you to solve. So using RH criterion for this characteristic equation, also comment on the location of the pole and the stability. Same thing. So s to the power 6 से लेके s to the power 0 तक लिख लेना है for route array. Then elements of s to the power all even, s to the power 6, then 4, then 2, and then 0. So it is what? 1, 5, 8, and 4. Then for s to the power 5, that is all odd. यहाँ से लेके 3 है coefficient. Next s to s cube, then s. So it is 3, 9, 6. So we wrote all the coefficient of these two orders, s raised to power 5 and s raised to power 6. Then I'm interested in this element, ye wala. So just above that there is 3. Cross multiply 3 into 5, 15, minus 1 into 9, that is 9. So 15 minus 9 is 6. 6 divided by this element, that is 3, will be 2. Let's go for the another element. Next जाते रहना है जब तक एंड नहीं होता है. दिस एलिमेंट, इसके इसको ही रेफर करके, इसके अब ये नहीं लेना है 9, इसको रेफर करके 3 into 8, 24, minus 1 into 6, 6. So 24 minus 6, it is 18. 18 divided by 3 will be of course 6. Let's go further. For this element, reference is this 3. Okay, don't move here, नहीं तो 4 के ऊपर 6 है, उसको लेके करना है. No, reference is this 3 into 4, that is 12, minus 1 into 0, कुछ नहीं है तो 0 कंसिडर करना है या छोड़ देना है सीधे सीधे. So 3 into 4, that is 12. 12 minus 0, it will be still 12. 12 divided by 3 itself, so it is 4. So we got the elements of degree 4, that is s to the power 4. Then move for s to the power 3. I'm interested in this row. Just above that there is 2. 2 into 9, that is 18, minus 6 into 3, that is also 18. 18 minus 18 comes 0. Let's go for the next again. एक 0 आया लेकिन आगे का भी देखना है ना, तो 0 आया लगेच एप्सिलॉन पुट करून नाही सोडायचं. नेक्स्ट भी कैलकुलेट करना है अगर एलिमेंट्स है तो. 2 into 6, that is 12. 3 into 4, that is 12. 12 minus 12, that is also 0. Now there is no further element to calculate. अगर है तो कैलकुलेट करना है आगे आगे. Okay, in this case initially क्या था, only one element in the column is 0, then we put epsilon, but here complete row is 0. Then we move to the just above that, और इसका हम auxiliary equation लिखते हैं. How to write auxiliary polynomial equation? सीधे सीधे लिखना है. कौन सा है वहां पे वो देखना है. That is क्या है, s to the power 4, means you will get all the even degrees. So as auxiliary equation will be ये coefficient into s to the power 4. So 2 into s to the power 4. Then s to the power 2 के लिए जाना है even, बीच में 3 नहीं लाना है. ये 6 into s to the power 2, and then 4 into s to the power 0 means nothing but 1. So this. Okay, again looking at the equation, coefficients are 2, 6, and 4. I may take 2 common, so it will be s to the power 4 plus 3s plus 2, and I will use this coefficient after differentiating polynomial, auxiliary polynomial. So I will differentiate this equation. I'll differentiate this equation with respect to s like this. So it will be 4s cube, then plus 6s plus 0, क्योंकि हमें यहाँ लिखना है ना, s cube के फॉर्म में चाहिए. So I'll derivate it. I'll get in the form of s cube, that is even को हमने derivate किया, you will get odd polynomials. So looking at this, what are the coefficient? S cube का 4, s का 6. So therefore 0 are replaced by coefficient that is 4 and 6. That is done in next. So मैंने जानबूझ के 0 0 रेड किया है जिसे मैं coefficient से replace कर रहा हूँ. Coefficient is obtained by auxiliary equation and derivating it. So it is 4 and 6. So I move here. In place of 0, I kept 4 and 6 in order. So I'll go for s to the power 2. The s to the power 2 का पहला element कैसे निकालोगे? पहला element ये निकालना है. Just above that there is 4. 4 into 6 is 24, minus 2 into 6, that is 12. So 24 minus 12, that will be 12. 12 divided by 4 will be 3. Next element यहाँ पे ये element. So 4 into 4, 16, minus 2 into 0, 0. So 16. 16 divided by 4 will be of course 4. या फिर ये उठा के यहाँ पे लाया तो भी कोई आंसर गलत होने वाला नहीं है. But I will tell you the procedure as well. Okay, I got this 3, 4. Then go for s to the power 1 order, and I'm interested in this element. Then how to calculate? Just above that there is 3, 3 cross multiplication, 3 into 6, 18, minus 4 into 4, 16. 18 minus 16 will be 2, and 2 divided by 3. So thereby it is 2 divided by 3 with positive sign, of course. And lastly, यहाँ पे कोई एलिमेंट रहता तो यहाँ पे आ जाता, वो नहीं है तो it is 0. Lastly, s to the power 0. I'll calculate for this. So 2 by 3 उसके ऊपर है, 2 by 3 into 4 minus 3 into 0 divide by 2 by 3. So 2 by 3 into 4 divide by 2 by 3 will be 4 itself. मैंने ये कहा है इससे पहले भी, अगर कैलकुलेट नहीं भी करना है, ये एलिमेंट के नीचे 0 है तो ये एलिमेंट डायरेक्ट यहाँ पे रिफ्लेक्ट होता है. Need not worry about it. जैसे ये हुआ है, you can see this element is just propagating down. Okay, now look at the first column of this route array. All the signs are positive through s to the power 6 to s to the power 0. All the signs are positive. So as there is no sign change in the first column of root array, therefore all the poles are located in left hand side of the plane. Let's calculate. इसमें ये क्या बोला गया है? Comment on the location of the poles. Location भी चाहिए उसे, and system stability. So we'll calculate the poles. So poles कैसे calculate करना है? Let's work on the auxiliary equation that we obtained. क्या निकाला था auxiliary equation? वहां पे लिखा है, फिर भी I will come here. ये auxiliary equation निकाला था because we got these zeros here. So auxiliary equation, s to the power 4 plus 3s plus 2 equal to 0. So we took this auxiliary equation. We took this auxiliary equation here. Then roots of the auxiliary equation निकालने के लिए we put that auxiliary equation equal to 0. Try to adjust that. I may write s to the power 4 plus 3s square plus 2 equal to s square plus 1, and s square into s square plus 2 is equal to 0. Okay, then I'll put s square plus 1 is equal to 0. Then I'll get s is equal to plus minus j. And if I get s square plus 2 is equal to 0, then I'll get s plus minus j under root 2. Means ये j का कोएफिशिएंट यहाँ पे 1 है, यहाँ पे under root 2 है. कौन सा ग्रेटर है? 1 is greater or under root 2 is greater? Yes, I want answer from your side. Which one is greater, you said? Yes, please answer.
Root 2 is greater, sir.
What is greater? I'm not.
Root
Huh?
2.
Root 2 is greater.
Under
Root 2
1
is
is
greater.
greater. 1 is greater.
You decide. You decide. Okay. So plus j and plus j root 2 is placed here, and minus j and minus j root 2 is placed here. What did you say on this? Are they repeated pole? I need answer. Okay. I'm asking question. Are they repeated pole?
No.
What did you say? I'm not able to listen.
No, sir.
Ho ka? Yes. Are you saying yes?
No, no.
No, yes. So it is not repeated. Repeated का meaning एक ही जगह पे double. That is repeated. These are not repeated. These are not repeated. और रिपीटेड नहीं है तो अनस्टेबल नहीं है। ऐसे चलता है, अलग अलग इमेजिनरी एक्सिस पे डबल पोल है लेकिन दे आर नॉट एट द सेम पोजिशन, देन the system is marginally stable. The system is marginally stable. I'll plot the response of this. I'll plot the response of this. Just wait. I'll plot first response of this. If I have only one imaginary pole, then response will be what? Response will be like this. And if I have double, not repeated but double, then my response is again bounded. My response is like this. Sinusoidal wave बरोबर निघणार नाही माझ्याच्यानी. I am using pointer. I don't have pen tab here. So this system is also marginally stable. This is also marginally stable because output is not going to infinity. It is bounded. And its integration, अगर आप absolute integration अगर लेना चाहते हो तो area is not integrable. It is infinite. Thereby it is marginally stable. पहले हमने एक एग्जांपल देखा, वहां पे रिपीटेड था, तो हम अगर रिपीटेड आया तो आपको अनस्टेबल लिखना है. यू प्लीज रिमेंबर दिस. एंड दैट कैन बी ओनली पॉसिबल व्हेन auxiliary equations are there. Go for the calculation of root of auxiliary equation, of course by straightforward way, or you may use some another method that you know, but calculate the roots, and after getting root, place it on S plane and accordingly come or what comment on the stability. Is it stable, marginally stable, or unstable? Because looking at this first column, all signs are positive. Directly straightforward you say that it is stable, but what is the answer? Answer is marginally stable, not absolutely stable. I'll move to the, let me see the time. I'll move to the last example that I have, that is example number 5, and somewhat a different example. I tell you what is the different. Determine the stability of closed loop system. एक फैक्टर है k जो आउटपुट से इनपुट में लिया है, that's why I'll say it is closed loop system. A characteristic equation is s to the power 4 plus 2s cube plus 4 plus k. ये कोएफिशिएंट है 4 plus k s square का, s square plus 9s plus 25 and 0. What will be the range of k for system to be stable? ये जो k है इसका रेंज बताना है जिसके लिए सिस्टम स्टेबल रहेगा. अगेन यू हैव टू प्लॉट रूट अरे, राउथ अरे, एंड राउथ अरे प्लॉट करने की मेथड विल नॉट चेंज हियर, इट विल रिमेन सेम. So I will use this characteristic equation. I'll write for s to the power 4, s to the power 3, then s to the power 4 means all even के हम coefficient लिख लेंगे. So you can see first s to the power 4 को 1 है, s square को 4 plus k, and s to the power 0 is 25. Then go for odd, s cube, then s. So s cube के लिए 2 है, then s के लिए 9 है. ये नहीं लिखा तो भी चलेगा, it is 0. नहीं लिखा तो भी 0 ही है. Then go for the calculation as we did earlier. That is this element I am going to calculate. How? उसके ऊपर 2 है, 2 multiply by this, so it will be what? 2 into 4, that is 4, 8. 8 plus 2k, 8 plus 2k minus 9 divide by 2. It comes k minus 1 by 2. Go for the this element. This element how to calculate? Again, first element in the order and a cross multiplication. इसके लिए जा रहे हैं हम. So this 2 multiply by 25, that will be of course 50, minus this will be 0, divided by 2, so it will be 25. And as I said, it will directly propagate उसके नीचे अगर 0 है तो. Now go for the next. ये निकालना है हमें. So it will be again उसके ऊपर जो एलिमेंट है ये वाला, this one, this multiply by 9 minus 2 multiply by 25 divide by this term k minus 1 by 2, and after calculation you get 18k minus 109 divided by 2k minus 1. Again, इसके below क्या है? There is a 0. So it will directly propagate here. Or you may try to calculate, you will get 25 cents. Now here, look at the signs. Look at the signs. Can you predict the sign for k minus 1 by 2? And yeah, 18k minus 109 divided by 2k minus 1. Can you predict the sign directly? Forget about this side. ये इधर जो मैंने लिखा है, don't see that. Can you predict? Of course, the sign is positive if k value is greater than 1 by 2. Else it is negative. But one question is asked, what will be the range of k system to be stable? Of course, k अगर 1 by 2 के greater है, तो system stable होगा because this term will be positive. वही हमें आंसर करना है. इसके 2-3 मार्क्स रहते हैं. ये अगर नहीं लिखा आगे, यहाँ तक लाके रखा है और you have not commented on stability as well as the range of k for closed loop system given, then of course 2-3 marks will be deducted if it is a theoretical paper, of course, means not objective. Okay, I'll say here what will be the range of k for system to be stable. So of course k minus 1 by 2 should be greater than 0 to system to be stable. Thereby k should be greater than 1 by 2. Again, coming to this element, 18 minus k 18k minus 109 divided by 2k minus 1 should also be greater than 0, so that this term will be positive. That is nothing but k should be greater than 109 by 18. And that must be of course greater than 1 by 2. That is greater than 1 by 2. So 1 by 2 से भी बड़ा है 109 by 18. So this will be the, I'll say threshold value. Hence, the system is stable for k all values greater than 109 by 18. अगर इससे नीचे अगर value रहा, system will be unstable. So we range दिया है, so it is more than 109 by 18, then system is stable. I hope whatever I taught, different concepts, different types of numericals, different ways to define stability, different ways to calculate and locate the poles based on auxiliary equations, we can say. I hope all the fundamentals are fitted in your mind. So if you have any question regarding, you may ask. Thank you. I'll wait for 1 or 2 minutes. Later on, I'll end this meeting.